Hi everyone, Senan this side, and in this video we are going to solve this Leetcode daily problem, which is string compression 3. So in this you would be given a string word, compress it using the following algorithm. So this is the algorithm, and in the end you have to return this string. So you start with an empty string comp, and while word is not empty, use the following operation. Okay, so what you have to do, remove a maximum length prefix of word made of a single character C, repeating at most 9 times. Append the length of the prefix followed by the character to the comp. So that may not be exactly clear. So let's look at this test case. So A, B, C, D, E. So you see we have A exactly one time. So we write 1A. B exactly one time, C exactly one time, D and E similarly. 1A, 1B, 1C, 1D and 1E. So observe the output could be longer than the input. So even though we are trying to compress the string, right? Now next let's look at this test case. How many A's can you see? So if you count them, you would have 14 A's. So the question is asking that at most 9 times, right? If it is more than 9, what you do is you consider it as a separate case. So what you do, you take first 9 A's and write 9A, then take the remaining 5 A's and write it as 5A. So you don't have to write 14A, but you have to write 9A and then 5A. So let's say if you had 18 A's, you will write 9A and 9A and not 18A. And then in the end you have 2 B's, right? So 2B. So that is the idea. And you are given that the word only consists of lowercase English letters. Okay, so we know for sure now we have to keep track of elements, consecutive elements, which are of the same type, or that means they are the same characters, and we have to keep track of the count as well, right? So that is what the idea would be, and the sequence also matters, right? So if 9 A's are here and 9 A's are after this B, they cannot be considered together. So the order also matters as well as the count. So that is the logic I would be using, and let's look at the solution on how we are actually going to implement this. First, you declare a string answer which you would be using to return the answer and count 0. So but in this case that was a different implementation. You don't actually need the count value. Now what you do is you declare a temporary vector which stores a pair of integer and character. This integer would be the count of that character and the second element would be the character. Now to not have the case where the temp is empty or not, what I would do is I would add a dummy node or a dummy element into this with a character which is not present in any of the word, right? It only consists of lowercase letters, right? So I'm using the pound sign or the hash. Now the next thing would be I would traverse through each character in my word, and what I would say that if the last element, right, tempts back, so last element's second, that means the character is not this character, that means I have encountered a new character. So let's say we were at this A, right? So after I have seen this A, my vector would have 1 comma A in that as an element. Now when I see B, that means this is not a part of my A, the first pair, the 1A. So that is why I would append a new element as 1ch, or ch, where ch is the character and 1 is the number of occurrences. Now we don't go into this if statement, we would be going into either of these two, right? But make sure that if we are going into else if or else, we know for sure that last element's second element and this current character are the same character, right? So we have consecutive same character. So in that case, previous characters first, that means the occurrence of the previous character, which is exactly same as the current character, is 9, right? So we can have at most 9 times, right? In that case, I would push this as a new pair because we can only keep at max 9 occurrences of any character. So in that case also, I would be pushing this into this vector. Otherwise, what I'll do is I'll increase the value of the last character. So I have, while seeing this character A, I would have in my vector 1 comma A. When I see this second A, I would update that 1 to 2. So 2 comma A. Similarly 3 comma A, 4 comma A, 5 comma A, 6 comma A, 7 comma A, 8 comma A, and when I reach to 9 comma A, and after that when I see an A, rather than going into this else, we would be going to this else if, and we would treat this as a new character or new pair into my vector. Finally, observe that I had a dummy pair in this temp. So what I'll do is, for this answer I want to resize this to the correct size. So in that case, new size is equal to 2 times temp size minus 1. This minus 1 is because I also have a dummy element. So basically, number of pairs I would have in this, you twice that would be the size of your string. Why? Because for every character you are storing the occurrence as well. So you have 5 characters with single occurrence, so you here have 10 characters in this output. So that is the idea. So you resize this to currently this new size, and after that, for every element or every pair in the stem, so I'm starting this from I is equal to 1 because the 0th index is the dummy pair. So what I'll do is answer j plus plus to 0 plus temp of I dot. This is actually converting. So temp I dot first is actually an integer, and I need to convert that into a character. So that is what I'm doing. I'm adding that integer value to this character 0. That would actually give me the character, and I'll put that into jth location. So I'm starting j at 0 and then incrementing j by 1. So now my j would be, let's j0. When I am at this position, my j would be 1, and j plus plus is I'm storing the corresponding character with that number of occurrences. And similarly, I'm going through this for loop till the time I have the temporary, and in the end I return the answer. So what is the time and space complexity? So the space complexity for this is basically big O of n, where n is the length of this word. Why? Because for every character you would be, let's say there is exactly a single occurrence of each character, or there are no consecutive elements with the same character. In that case, every character would have an occurrence of 1, and since in this case, since every character is different, the output is the twice the size. So that is why the worst case temp would be storing twice the number of characters in this. Now in this case, what we are going to be having is a linear time, this for loop, and again another linear time for this for loop as well. So the time complexity for this would be big O of n. This is a constant time operation. So yeah, the answer, if you the space for the answer as well as the time, it's both big O of n. So the space complexity for this whole answer is big O of n, whereas the time complexity is also big O of n because of these two for loops. So, would say big O of 2n is the time complexity, but you omit the constant in time and space complexity analysis. So yep, that is the video. Hope I was able to explain this to you. Before you leave this video, I just want to tell you that the whole written solution is provided in the description below. Be sure to check that GitHub link so you can download the PDF of this as well, and I'll see you in the next video.